This is me watching
Look
your
at origin
videos.
appropriately.
I'll just take clips
Take
of
your
each
flow
one.
sensor,
Probably
plug
like
it
10
into
seconds
the
each.
go link on a cylinder. So here you have your
Usually
cylinder. We're going
next
to
one.
take the drag measurement with this profile. Okay, this lesson is going to be on how to expand flow. What you do is to do Reynolds number comparisons or adjusting the Reynolds number for your particular model. So
Ignore Reynolds number.
Now again, remember, do not put any objects or hands inside the back end or front end of the airflow device.
Here's the interesting one.
Okay, this is the demonstration of how to perform experiment 2.8, drag on a sphere. First of all, let's go over how to attach. Go around that way, then fold it over, cross it over. So your rubber band will go around all the edges. Then what you'll do is you'll take your piece of fishing line and string it through this particular part and let it hang down. So when you're performing your experiments, you didn't put the wind tunnel outside with the electrical cord up. What you can usually do is keep the profile and again adjust the height as needed. Tape it down to have the long profile. Just simply place your force sensor in there and then again use your clamp. Clamp it in 2.9. A block. Measuring the drag on a block. Okay, so in the homework it says to perform the drag calculation for a long profile and a blunt profile.
A block instead of
So the very first way you're supposed to go about doing it,
circle.
perform the experiment,
Well, the
is
sphere.
with the long, almost mimicking a flat plate, but now it's not going to be really thin. You're going to have a profile in the front.
Okay, here's my calculated force on each profile from the addition of air mass. Compare the calculated force with the measured force from the data provided. Hint, look at example problems. Okay, so, shoot. Can't see close enough of any of these things. Okay, so I followed the formula. Mass flow rate equals density times your area times your velocity. So your area I calculated, and here it's 3.1459 times my diameter divided by 2 times Earth squared, since this was a sphere. Anyways, these are provided here. The area was not. The density of air, this is an assumption. Just so you know, I just assumed the density to be 1.175 kilograms per cubic meter. So this was all calculated using kilograms. This is what the force was measured with your device. However, this is my mass flow rate. So you take your mass flow rate, you times your velocity. So basically PAV squared. And these are the values I got: 0.001, 0.011, 0.0266, 0.068. And I noticed that the values that I got were closer, at least with some of these, were closer to the secondary numbers. So this first one's 0, but the second one you read was a 0.005. Well, that's closer to the first one I have. And this one's 0.014, and this one I have 0.0118. This one's 0.0266, and that's 0.0270. So I don't know, that seemed to be across the board, similar numbers for the last one instead of what I got. So I don't know what kind of relation there is there, but that seems to be, I didn't get the same numbers, but that seems to be the difference. Very similar numbers with one down from what you have. But anyways, so this one, I did length in inches, sphere diameter, like, I actually probably did that wrong. When I calculated my area is wrong in that actually, now that I think about it. But these are my flow rate, that's my force on the object, my velocities. This is the same here. So I calculated this wrong now that I think about it, because the sphere of diameter, well, I didn't know with relation what direction you really had it, to be honest, but I assume one was with the circular part facing this way and the other was, it would end up being more like a square. And now that I think about it, I did this area, I just did as, what did I do this area as? Oh, I was dumb and I just times it by the diameter. Well, actually, no, that's right. What am I thinking? Because my diameter would give me my height of the square. Oh, never mind. So that's accurate. So these should be right. I did not get the same numbers, as you can see. My top number is 0.606 and you got 0.42. I got 0.030, which is actually a lot closer here. These numbers are a lot closer to what you got over here. This last one was the one I wasn't sure which way it was really facing, because you got your depth times your length. I calculated one that way. So you can see over there. Actually, let's just double click it. Should have read them up, yeah. And then the other one I assumed was this one, length time width. So that's my assumption there. And I did each of these, you know, with the respective, you know, areas. This one's with the second area, so. And then I calculated each of their forces using that. When you said to create a linear function, for some reason I just thought in my head that you were saying to create a graph. I mean, if I knew linear regression from this, I could create a linear function out of this, but if I were to create a linear function, I'd just take a rough estimate from here to here probably. But that doesn't really give you values, and I should have looked up how to really do that. Model you, I mean, it'd be pretty easy. You just create some sort of slope off of your forces versus your velocities, and I mean, that's literally what this represents, but it's not in a linear function formula, which I didn't do. That's my bad. But I did all this other junk, and I did all the videos. I've talked to someone, well, we've discussed in my group a little bit, but I really didn't know how to do any of this until just barely. And then one discussion with another group, haven't done that yet. I'll probably send some of my info to another group, but that didn't really happen, so I had to do it all tonight, unfortunately. Here's some of the discussion in our group. Really not too much. Gavin Thomas mainly led it. He talked about the formula, which I later found using one of the not an example problem, but like one of the problems we had to solve, and I looked it up and found solutions and to figure out what formula they were using. They used the mass flow and then times the velocity again, which is essentially what this is. So that's the way I did it in my formulas. This is what he provided. He talked about that. His numbers were he was getting really messed up numbers apparently. And I feel bad because I wasn't able to really do anything until late at night. I had work until late. But I got numbers. I responded that. I got similar numbers to what you had. So I listed here, I think source of error, maybe that I did not know the temperature he took as values at. The density of the air depends on the elevation and temperature. So I had very similar numbers when you talk about scale-wise, but it was not the same. But compared to what Gavin's had, mine were similar. But so I didn't know what temperature density value, air density value you were using. I explained that in my other video.